Hi, I'm Dave Armlin, VP of Customer Success and Solutions Architecture at Chaos Search. And I'm very excited to be here today with Alex Rasmussen. He's a principal cloud economist. Sorry, that's not a mouthful. It's a very important job at the Duckbill Group. Alex, wanted to thank you for joining us today on the podcast.
Thanks for having me, Dave. It's great to be here.
Awesome. Well, you have a very impressive background and resume. You have a PhD in computer science from UC San Diego, and you've been in a number of roles. Going back to your graduate school work, you've been a VP of engineering, you've been a consultant in the big data space, and now you're ending up as a principal cloud economist at the Duckbill Group. That's quite a journey. Why don't you give us a little bit of background about your experience with big data, solving big problems at scale, going back to your days as a graduate student?
Sure thing. So let's see. Let's go all the way back to the beginning. As you said, I went to graduate school in UC San Diego. My dissertation there was focused on efficient, large-scale data processing. So, how do you do a bunch of computation on a bunch of data with as few physical resources as possible? We focused on large scale sort for a long time. Sort kind of is the backbone for any large scale distributed data processing problem. And ended up, we were at the time, we were competing against a cluster of Hadoop nodes that Yahoo was running. And we managed to get, I think, about 60% better kind of performance in absolute terms with an enormous number of fewer machines than they had. I think they had something like 3,600 machines. We managed to increase the wall clock time, or well, I should say, we made the wall clock time better by 60% with about 50 machines. So 3,600 down to
Wow.
50. We extended the sort system shortly thereafter to do MapReduce jobs. So making the kind of workload a little bit more variable, making the data a little bit harder to predict in advance, and managed to set a few more records in large scale processing that way. Um, and yeah, so that was graduate school. After graduate school, I went to work at at the time, a tiny data startup called Trifacta. And that was actually something that came out of a relationship that I had built as an undergraduate at UC Berkeley. Joe Hellerstein, who was one of the co-founders of the company, reached out to me when I was on the job market and said, "Hey, I'm starting this new thing in self-service data preparation. Do you want a job?" And it was a bit of a departure from what I'd done before because my grad work was on kind of rocket ship data processing engines, and I moved into kind of more of the application side of the space. I was at Trifacta for about 4 years, and went and spent a couple of years after that as a VP of engineering at a biotech company called Freenome. I was an early employee there, also kind of built their engineering organization. And after that, I spent a few years working as a freelance data engineering consultant, mostly working with startups. And then for about the last 3 or so months, I've been a cloud economist at the Duckbill Group. So I've been kind of all over the place in my career.
Awesome. And, in that journey, you certainly have worked with, concepts and ideas in the academic arena, and then open source projects that became, quite popular. And certainly the boom of Hadoop and Spark and all of those things. At Chaos Search, we're very much excited to be able to take advantage of data at very large scale, inside cloud object storage, and to make that a highly searchable and thing that folks can bring data lake philosophies together. One of the things that I think that era with Hadoop tried to tackle. What kind of challenges did you face as you tried to solve those types of problems with those tools and during that era? And where do you see things headed now? And some of the things that you get excited about relative to new products and solutions.
For sure. So I guess when I was in graduate school, I was kind of in the same kind of rough academic cohort as Matei Zaharia, who wrote Spark. And so at the time, Hadoop was a big deal. The kind of broader community was very excited about big data and kind of large scale processing in MapReduce. Very quickly, Spark kind of came onto the scene and took over from Hadoop, and I saw that transition beginning to happen while I was in graduate school, but it very much kind of snowballed while I was at Trifacta. I think the shift that's happened, in the time that I've been around has been fairly large, right? I think that um, the thing that Hadoop kind of introduced to the broader world was this kind of art of the possible, right? We moved from this world where you had these large monolithic database systems, and that was kind of what you had, to this new environment where you could spin up these horizontally scalable clusters of machines and process enormous volumes of data. And for the first couple of years, people, I think, were focused on like, what can we do with this thing? Like, what can we express with it? What kinds of computation can we do? How big can this thing get? And how efficient can it be done? And I think a lot of what I focused on in graduate school was on addressing some of the issues that Hadoop specifically and MapReduce more generally had with respect to its efficiency, right? And trying to make sure that those systems took better advantage of their hardware. I think that when we got into the Trifacta years, um, what we were seeing was that a lot of companies, especially large enterprise companies, had started to build these large on-premise Hadoop clusters. And a lot of it was kind of, well, we've got this big cluster, we've got all this data sitting around, now what do we do? And I think
Mhm.
that Joe and the other co-founders of Trifacta correctly realized that one of the big problems that existed back then, and still to a large extent exists now, is this problem of the data has to be good in order for the analysis that comes out of it to be any good. And so people were spending a lot of their time preparing that data for analysis, and Trifacta tried
Mhm.
to democratize that and to move the data preparation process into the hands of non-engineers, just so that that process could go faster. Um, and I think that especially over Trifacta's lifetime, what you saw was that initially there was a lot of skepticism around cloud and around cloud data processing. And by the time I left Trifacta, that skepticism was starting to go away. Now I think that it's very much gone. I think that the enterprise has embraced cloud to an enormous extent. Um, but now we kind of find ourselves in another interesting situation where once again we find companies with an enormous amount of data that they've got compiled, and they again are asking the question, well, I've got all this data, now what do I do with it? Except today the answer to that question is something machine learning. And so
Right,
um,
right.
it is one of those, the more things change, the more they stay the same kind of things. I think that in many ways we're seeing the same kinds of challenges just presented in a slightly different way now. But the underlying
Mhm.
technology and the kind of the way that that's deployed and the way that that's operationalized has changed an enormous amount in a relatively short period of time.
Right. And, would you say that similar to when you were in the on-prem era and until, you described how folks became more comfortable with the cloud, are we just
Mhm.
providing tooling to kind of climb the stack and allow folks to solve higher order problems and removing, some of the more monotonous tasks? I think your career has spanned, a lot of roles and new positions kind of grew up in that period of time that you're describing.
Yeah,
Data
I mean, I think that
engineering, data scientists.
yes, yes, especially like the rise of the data engineer, the rise of the analytics engineer. I think in some ways what you're seeing is a movement up the stack in terms of like, and I think that kind of comes along two axes, right? It's the how are you deploying this thing, and how much do you care about the thing once it's deployed, and what are you actually doing your analysis in, right? Back in the on-prem Hadoop days, you were writing. I mean, unless you were writing in like Pig or something like that, you were writing raw map and reduce tasks that you would deploy as a jar to an on-prem cluster of Hadoop nodes. And
Right.
it didn't take very long for people to realize how awful that was from an operational perspective, from a workflow perspective. It just was a real drag. And I think over time, you've kind of seen that has been was supplanted by Spark largely, and that on-prem cluster has kind of migrated into a managed service of some kind. But I think what you're also seeing now is with the rise of things like cloud data warehouses, the BigQueries and the Snowflakes of the world. You're starting to see how that's being expressed change as well, right? So whereas before people were talking about, oh, well, you have to know Spark to be a data scientist, and now it's like, well, you can kind of speak SQL no matter where you are. So if you know SQL, you're good. And I think a lot of that comes down to we iterated on the technology a few times, and we came up with some things that were relatively easy to reason about, and so we could build things into like query planners and so forth that would produce efficient execution plans for this stuff without people having to cobble that together themselves, right? I think that particularly this kind of decoupling of compute from storage that we're seeing with these cloud warehouses like Snowflake and BigQuery, that decoupling is fundamentally it's fundamentally changed the way that people who build these things can reason about them, which makes them a lot easier to kind of to throw SQL at and have a query plan get turned into some kind of an execution that makes sense, as opposed to the previous way we were doing things, which was you are the query planner and the physical plan you generate is a Spark job.
Right, right. Well, that's a great evolution, and certainly things are a lot a lot easier now, and certainly
Yeah,
doing pig and having to kind of handcraft MapReduce, is something that's just gone by the wayside. So that's great news.
absolutely.
Certainly your point about separation of compute and storage. We at Chaos Search are delighted to be able to bring our distributed indexing technology where data lives in cloud object storage, and we bring compute near the data to index it and provide querying capability. But there's a complete separation. Our compute is really a stateless fabric that comes close to the data to provide indexing and query capability. So you mentioned how SQL is kind of the lingua franca, and you also in your journey kind of covered both the relational database world, that I think the last time we spoke a little bit about the NoSQL wars, and then kind of
Oh yes,
evolving
that's
to where
right.
we are
We haven't
today,
even
where
covered that, have
you've
we?
got data all over the place. Yeah, definitely.
Right. Yeah, I mean, I think that now, as you say, like there was a time that was kind of uh, happened at about the same time that the rise of Hadoop happened, where there was this kind of fragmentation away from SQL and into all of these other kind of new SQL or NoSQL systems, and that uh, was a very chaotic and very interesting time. And ultimately, I think what we've realized is that there are a handful of models that clearly kind of came out of that kind of tumultuous period relatively unscathed. Right, MongoDB did very well. There are a handful of others, but I think that ultimately we're seeing this kind of return back to SQL as like the lingua franca of data analysis, which has its good parts and its bad parts, right? But it was very interesting to kind of see that explosion, and then ultimately people kind of looked around and went, "Well, what is this doing that SQL isn't really doing? Oh, well, not much. Maybe we should just go back to it." But I think that a lot of what you see now is this, especially over the course of my career, this kind of movement from single monolithic thing that does everything, right? Single monolithic database engine that has all the indexes and all the data and all of the physical representation and all the compute and everything else. And I think what you're starting to see now is that there's starting to be a little bit of fragmentation, right? So you have like search and indexing can live over here, and large scale object storage can live over here. And, all of this stuff can kind of coexist, and you're not necessarily reaching for the kind of one all singing all dancing tool that does everything you want. Now the flip side of that is that, especially right now, we're seeing this profusion of tools, and it's very difficult for the average consumer to make any sense of just the market overall, and like, what do I even need, and what do I buy, and who do I buy it from, and how do these things fit together? And like that is a big challenge these days, I think.
No, I definitely agree, and certainly it's difficult when you hear a lot of the same messaging from different companies. At in
Yes.
your current role, how are you guys working with companies that may have multiple technologies in each cloud to tackle things? Or do you consult on that front, or is it more just kind of an economic kind of cost control
So
engagement
I
for you
should
guys?
probably explain like very briefly what Duckbill Group does. So
Yeah, great
we're
point. Great point.
we're a boutique consulting firm that specializes in cloud cost management in AWS specifically. Um, and we take a fairly unique approach to that problem. And I think one of the big pillars of that approach is this kind of understanding that in a cloud environment, architecture and cost are kind of the same thing, right? In a sense, it's everything is pay for what you use, or most things are anyway. And so what your architecture looks like and how your software is built and kind of dictates how that software is going to cost in AWS. And in many ways, controlling your cost is really more about making sure the architecture looks good and making sure that the cost of that architecture can be tied back in to the business's unit economics, and making sure that every dollar that you're spending in AWS is correlated to hopefully at least a dollar of revenue somewhere else. And on the data front, that takes a bunch of different forms. So obviously, we have a lot of customers that use a lot of S3, that use a lot of RDS. We also have a lot of customers that use the kind of higher level constructs that exist within that ecosystem, Redshift and DynamoDB and things like this. And in a lot of ways, my job is working with the customer to see what they've got, number one, to see what they're trying to do with it, and then to recommend ways that we can make that process more efficient from an architectural perspective and kind of by extension from a cost perspective. So, and it very obviously, I
That's great.
can't really say anything in detail about what the customers are doing, but like that is generally the nature of the job. And as a consequence of that, I think some of it comes down to choice, right? Like, should you be using a relational database for this, or should you be using a key value store for this, right? And a lot of it comes down to just how much data are you retaining and for how long. Are you storing stuff that you're not touching in tiers that cost a lot of money when you should be moving them into tiers that don't? But like, this is another, I think, example of when we moved into kind of collectively as an industry, when we moved into a cloud footing, um, there were some that said, we will move into the cloud and suddenly all of our problems will be solved and everything will be easy. And it turns out that that's not true, right? It never is. We just replaced problems with other problems, and some of those problems went away, but others, like if you have a rack of on-premises machines, you know exactly how much to a first approximation those machines are costing you every month, because they're turned on and plugged into power and they use some amount of electricity and you have to pay somebody to maintain them. In a cloud context, there are things that you never would have thought would have cost any money that suddenly things like logging becomes really expensive, and you have to start thinking more about like, how much am I logging and to where. And so those are the sorts of things that I and kind of by extension Duckbill Group help customers with.
Yeah, that's great, and I think that's a great answer. And I can, looking at your background, I can see how you could add so much value, in that conversation as you ask good questions of your
Yeah,
your
thanks.
customers to make sure that they're doing things efficiently. And certainly, Chaos Search, I think one of the things that we've heard, where people have multiple copies of data and data is moving around. We firmly believe that you can um, reap value directly, business value directly, quickly, right out of cloud object storage. So a lot of solutions are, moving data from there to other locations, and then sometimes bringing it even back yet again. So you're, get
Oh
the
yeah.
multiplier effect of movement and cost of movement. I know one of your colleague Corey Quinn, I've heard him rant quite often about the charges of network fees, et cetera, as you move things between regions, et cetera.
Right.
So the efficiency, I think, to your point about architecture, is really key. So that's great to hear that you're adding value there, and love the approach that you and the rest of the Duckbill team bring to your customers.
Oh, thanks.
Certainly, you also mentioned another thing that's near and dear to our heart is and it's logging.
Mm-hmm.
All of these cloud services. One of the things that came to mind as you talked about the on-prem rack, it's extremely easy with just a few clicks of a mouse or just a couple of commands to, move and generate terabytes of data, either on purpose or inadvertently in
Yes,
the cloud. So
exactly.
in some ways, that ability to incur cost is enormously easy to do. So I know you and the team there must help folks with that, and certainly at Chaos Search, we are very cognizant of how we can help people with that problem.
And I mean, I think bringing it back to kind of to history, right? I think that we've moved from a world where a lot of what currently costs an enormous amount of money, it just was impossible 20 years ago. Like it was something that you wouldn't even think to keep every single weblog that you have ever generated in the history of time. And now, we've kind of moved, I
Right.
would say, like we're in the middle of this thing where people are still largely kind of just hoarding all of their data in one place and going, eventually we're going to figure out what we're going to do with this. And now there's this movement, especially with regulatory pressure and cost pressure together, that are causing companies to start thinking more strategically about, like, okay, well, the technological problem is not necessarily solved, but like there are a lot of things that we couldn't do before that now are just kind of routine. And given that, what do we do, like what do we actually want to log, how do we actually want to retain this, like how are we going to deal with things like data governance and all of that other stuff that comes along with having all of this data sitting around. And I think that machine learning has given us, finally it's given us like a concrete output to which all of this data is an input, but a lot of the same problems, the data cleanliness problem, the data recency problem, like all of these problems are still there. They just are not, like the nuts and bolts of the mechanism that got them there is not necessarily as directly visible to engineering teams as it used to be, but a lot of the same challenges are still present.
Absolutely. And you did describe earlier how ML has become a big part of the conversation now. Where would you say we are in the hype cycle with ML and AI, and how most businesses can take advantage of the either the cloud services or some of the great products that are out there in that space to differentiate themselves and solve real problems. Where would you say we are in that journey?
Great question. This is something that came up a lot when I was a freelance consultant. Um, I think at a 10,000 foot view, we are still very much in the Wild West when it comes to ML. I think that there has been an enormous amount of amazing work done, especially in the image domain, in the natural language domain. It just huge strides have been made in a very short period of time. But in terms of the end to end, kind of what people are calling the ML ops life cycle, right? The process of going from an idea to a production model that you can iterate on. It's still very early days. Um, and I think that also, in much the same, like, well, let me put it this way. Machine learning is clearly an output for which all of this data is an input, but I think that we're in the same sort of point in the hype cycle with machine learning that we were with big data back in, let's say for the sake of argument, 2012, 2013, where a lot of people are reading about this stuff and going, oh my god, this can do incredible things, I really want this for my business, but how do I do it? And is there any there for my business? And I think that the advice that I've given often is, if you feel like you have a problem that machine learning can solve, the first question you should be asking is, can I solve this problem realistically without machine learning, right? Um, and in particular, like if I have a problem that the domain is very easily separable and I can just draw a line between the two classes, just draw the line between the two classes and have done with it, right? Um, but then as uh, you examine the problem, I think this is a thing that I've found a lot throughout my career, is that the important part is not necessarily answering the question, it's asking the right one. And I think on the machine learning side, I hear a lot of activity around, like, how do I solve problem X with machine learning? And not a lot around, like, is problem X a problem that I need to solve with machine learning? I think on the flip side too, like,
Right.
we're starting to see a backlash a little bit, right? I think on two fronts. I think on the first, a lot of businesses have invested a lot of time and energy in machine learning initiatives that have gone nowhere, which is kind of the same thing that happened to big data. A lot of people bought a lot of big Hadoop clusters, and they sat around and sat around, and eventually they came up for renewal, and people went, well, we're not going to renew this. We didn't do anything with it. And that's unfortunate, I think, because
Right.
as a data person, I feel like that threw the baby out with the bathwater a little bit. And on the machine learning side, that's where I'm seeing, like, especially people, I think people have an overinflated sense of what it's capable of in a lot of cases. I think there's a lot of kind of back pressure on, like, hey, some of the stuff that this is being used for, maybe it's not ethical that it's being used for these things, right? And the conversation is moving in that direction.
Sure.
And what I really want to see personally is this movement toward, like, let's start with the question that we want to ask. Let's start with the problem that we want to solve. Then let's consider what the technological solution to that problem is once we really know that we understand the problem. And if we do more of that, then hopefully what comes out of that is this a larger volume, let's say, of useful output, which will hopefully prove to the industry at large that, like, yes, there is something there. It's just not the all singing, all dancing solution to all problems.
Right. Well, I think you nailed it. Certainly, there's always this shiny new object syndrome
Yeah.
that we get in tech, where everyone wants to apply that new thing to any old problem, and often it may just be better business rules to look for that anomaly, and the anomaly is just really a value that falls in a range.
Yes.
You don't really need to train any model for that. It's just setting bounds on it and checking values. So, I think hopefully we can snap to on that and apply it to the right things, and use it for ethical things. So certainly, we had a guest earlier on this podcast series that talked a little about the inferential things that you can do with AI, which I hadn't thought much about, but certainly provided some pretty thought-provoking things about the ethics of the data involved, and how it can come up with answers that are interesting relative to ethics and bias and those
For
types of
sure.
things. So, what types of you know uh, products and tools are you excited about, and outside of maybe your Duckbill group, or things that you're doing to keep your gray matter flowing, and excited about the new things that are
For
out there?
sure. I mean, I think that the database nerd in me loves the fact that cloud warehouses are doing as well as they are right now. Um, I think that one of the things that is really interesting, I think, at the moment, is trying to figure out what the broader data organization looks like in 5 to 10 years. I think that right now we're at a point where we have all of this kind of profusion of titles, and we have kind of rough organizations for how those titles work and kind of who they report up to. But how the data team, so to speak, fits within a broader organization, and what their role is and what their outputs are supposed to be, I think, is something that I find really exciting. Just kind of like the organizational architecture, right? Like, I read somewhere that the recommendation is that you should have 2 to 3 data engineers for every data scientist in an organization, and that seems kind of scary to me personally. If I were someone who was trying to staff a data organization, that sounds really, really expensive. It sounds like I'm going to spend 2 years trying to hire those people. Um, and so, I think the big questions that I've kind of been asking myself are like, we have these amazing tools that are democratizing access to analysis at scale in a way that we've never seen. But I think in many ways, we still don't really understand how to direct all of that energy. And I think there are things, cloud data warehouses again a thing that I'm really excited about seeing where that goes. I think on the other hand, you see tools that are emerging now that, like, take DBT as an example, right? Relatively speaking, very simple tool, bunch of SQL queries. But the key thing is that, like, the relationship between models inside of this system is explicitly encoded in the thing itself. And so much you can do so much with that information that you would have to kind of guess at or infer before. And I think in the data space, there are still so many other places, not just lineage, but governance and data sensitivity at like a per column or a per record level and all sorts of other stuff like this, where it still kind of feels like we're kind of rubbing sticks together to make a fire when we really should have a lighter by now, you know and like, those are the things I think that are
Right.
really exciting for me, is to just kind of see, like, I'd like to see us get to a point of maturity with this that's similar to even the level of maturity that we're at right now with general purpose software engineering, where, like, people can build big, complicated stuff and it doesn't just immediately collapse under its own weight. And we're getting there for sure. I'm extremely confident that in 5 to 10 years, we'll be in a much better place than we are now. But it's a very exciting time. It's a very dynamic time. There are a lot of people with a lot of opinions about how this should be done. And I'm really excited to see how
Hmm.
it shakes out personally.
Awesome. Well, certainly, I can sense the passion that you have for that, and all of the optimism you have for seeing this space and the products explode there. You kind of captured, I think, one of the things that we try and call our mission at Chaos Search, and that's democratizing access to data at scale. And certainly, I think, as you described, how you could see, organizing data and all of the things that come with data at scale, and the products and opportunities
Hmm.
that come there. It's a pretty exciting world to live in right
Absolutely.
now. So that's great. So Alex, it's been a great pleasure to chat with you today. Where can we connect with you? On Twitter, your any sites that you want to recommend that we visit relative to podcasts and other things. Where's your watering hole
Sure.
for
Well, I mean, first of all,
information?
thank you for having me. It's been a pleasure. In terms of where people can find me, I'm on Twitter at Alex Ras, Alex RAS. My personal website is alexras.info. Um, I still have some writing up on the web from my freelance days at bitsondisc.com. Uh, Duckbill Group obviously is where I work. Duckbillgroup.com. Tell your friends. Um, yeah, I mean, honestly, like, feel free, if anybody in the audience is interested in talking more about this stuff, feel free to ping me on Twitter, or contact me through any of those other means. More than excited to nerd out about data stuff some more.
Awesome. Well, really appreciate the time, and certainly we'll check you out on Twitter and the Duckbill Group as well. And thanks again for your time
Happy to.
today.
Thank you, Dave.